Hey there, how's it going everybody? In this video, we're going to be learning how to use Tkinter with classes. Now, if you're following along with some other tutorials from other sources, this may be one of those things that they don't cover until later on, but in my opinion, this is something that you should be doing almost immediately with Tkinter because it's going to save us a lot of headaches down the road. Even when building small, simple applications, I think it's important to get into the habit of using classes, and we're going to see why in this video. It's not only going to help us with easier layouts and organization, but it's also going to prevent a lot of headaches and ugly workarounds that you'll find yourself using if you're not using classes. Now, we're not going to go into anything super advanced here, but if you're completely new to classes and have never used them before, then I would recommend watching my series on how classes work in Python, and that should give you a better idea of the basics that we might not touch on in this video. Like I said, we're not going to go into anything super advanced, but I will be going into this tutorial with the assumption that you know how to create, very simple applications, how they're initialized and things like that. But if you don't know those things, then I'll leave a link for my series on object-oriented programming in Python in the description section below. But with that said, let's go ahead and get started. So I already have an example of a problem that we can run into when not using classes pulled up here in my editor. Right now, we have a very simple application that we've created with Tkinter, and this is the same code and application that we ended up with in our introduction video. Now, if you missed that video, then I'll have a link to this code in the description as well. But basically what we have here is an application where we just have two frames. So right here, we have one frame, and right here we have our second frame. Now, by using those frames, it allowed us to organize our code a little bit better. But there should be a problem here that's kind of popping out to you that is pretty common, and it can make code unmanageable pretty quickly. So when we created our second frame, we reused a lot of the same code from above. So you can see that this frame 2 here, basically we just added a 2, added this to the second column, and all of that code is basically the same as all of this code, but we're just creating a second frame and only changed a few things. So anytime that you're repeating yourself in programming, it's usually a sign that there's a better way to do things. But the repetition isn't the only issue that we have here. So let me run this and we'll see what I mean. So we can see here that we have a simple application that has two input forms. Let me make this a little bit larger here. And these are side by side. Now on the left, we're using themed Tkinter frame, and on the right, we have a regular Tkinter frame. And using frames allowed us to simplify our layout and easily add this second input form on the right side by just copying and pasted the code that we had from the first frame. But there is an issue with the code that wasn't addressed, and some of you noticed this and left a comment about it. Now, I actually introduced this bug on purpose into our application because I wanted to show how if we used classes, then we would never run into this problem to begin with. So what's the bug that I'm talking about? So let me go ahead and try to add in some information here. If I try to insert anything into this left form, it doesn't work. If I do it in the right form, then the button seems to work and my enter input seems to work. But it seems that this left form is broken. So let me close this down and go back to the code to see why this is. So if we look below our first frame here, then we can see that we have this entry binded to our return key here, and it's bound to this add to list function. So now if I look at my second frame here, then we can see that we created another widget called entry, and that we've added that to our second frame. And we're also binding that to an event so that when we hit the return key, it runs that add to list function as well. Now, you might be thinking that the bug simply comes from using the same variable name for both of these widgets, and that's part of it, but changing that alone won't solve our problem. Let's go up to the add to list function and see what this looks like. So here we have our add to list function. So there's another issue within this function that should kind of jump out to us here as being what's known as a code smell. And that's that we're accessing variables from our global main namespace within this function. So for example, we are accessing the entry and text list objects here. And it's not immediately clear just from looking at this function where these are actually coming from. So that's one issue. And we can see that within this function, we're specifically getting the text from that entry widget and then adding that text to our text list. So the fact that we did use the same variable name for that widget is part of the problem because now this entry widget is specifically referencing the entry widget on that second frame and not the first frame since we recreated that. But that's not the entire problem. Even if we were to rename this to entry 2. So if I were to do that, let me go ahead and grab all of these, rename this to entry 2. Let me take that out there. Then now we just have that same problem in reverse. Now that add to list function is going to be referencing that entry widget from our first frame, but not our second frame. So what we need here is for our function to reference the entry widget and the text list of the specific frame that's calling that function. Now, there are ways that we could get this to work without classes, but those would take some workarounds with using lambdas or wrapping functions within functions and stuff like that that can get kind of confusing pretty quickly, especially to maintain. Not to mention that we already have repetition and global variable access in our code that I mentioned before. So with all that added up, the better way to do this would just be to use classes. So let's convert what we have here now to classes, and we'll see how much this cleans everything up. So first, let's go ahead and do the bare minimum and simply create a class that creates the most basic application. There are a few different ways that we can do this, but I'm going to comment out almost everything that we have so far. So all the way up to here, I'm going to comment out. And now the way that we can create an application that's basically empty is from these lines here. So first, let me show this to you without doing this with a class. So I'll say root equals tk.tk, give it a title, and then we want to do a root.main loop and run that loop. So if we remember, that's a very simple empty window. So if I run that, we can see we get an empty window. And now let's create the simplest version of a TK application using classes. So I'm going to show a few different ways that we can use classes, and then I'll tell you my preferred way. One way that we can create a class is to create one that does not use inheritance. So that would look something like this. I can just say class application, and then within here we need our init function. So I will go ahead and create that. Whoops, and I thought I had my tab completion off here. I don't want it adding in a bunch of stuff that's going to confuse us here. I just want to focus on what we currently have. So now within our init function, we need to initialize this. So I can just say self.root is equal to the same thing that we did here. And actually, I can just take everything that we have here, put it inside of our init function, and all I would need to do is put self in front of this, and that should be enough to give us our very basic app using classes. So if I say app is equal to application and create an instance of that, if I run this, then we can see that we still get that blank window there, but instead of creating it outside of the class, we just created everything here inside the class and then created an instance of that class. So the approach that we're using here creates this Tkinter instance within our application class itself. And we can see that that worked, but if we wanted, we could also create the TK instance and run the main loop outside of the class. So to do this, we need to pass in the instance of TK as an argument to our class. And we can do that by adding it as an argument here. And since we want to create the TK instance and main loop outside of the class, all we need to do within the class is change things like the title. So I'll just set self.root is equal to that instance that we're going to pass in there. And then we can just set the title. And now outside of here, I can say root is equal to tk.tk. And then we can pass this in to our application class, and it passes that into the init method there, sets the title, and then from outside the class, we can run our main loop like that. Now, if I save that and run it, then we can see that that works as well. So now I'll close that down. So with those first two ways of creating classes like we did, one where we created the instance inside and one where we created it outside, we can sort of think about this in the sense of saying that our application class here has a Tkinter instance. It's not a Tkinter instance itself. If we wanted to make it a Tkinter instance itself, then we can inherit directly from tk.tk. And this is my preferred method because I feel like it makes more sense and helps organize the code better. So to inherit from tk, we can simply add that to our class definition. So I'm going to take this here without the parentheses there because we don't want to create an instance. And I think I messed that up while I was moving things around. This needs to be tk.tk. And now we no longer need to accept this instance as an argument. So I will remove that. And another thing that we need to do, I'll go ahead and remove this as well. Now, another thing that we need to do here is to run its constructor. And to run its constructor, we can say super dot and run that super's init function. And that's basically the same as what we did down here with running tk.tk. So it's just initializing that parent class and then allowing us to make our own customizations after that. So now, instead of us thinking about this as our application having a Tkinter instance, now we can think of this in the sense that our application is a Tkinter instance. So instead of self.root.title, we can simply say self.title because this is the instance of tk. You can see that I also removed that self.root equals root because that's no longer needed. And now, since our application actually will give us an instance of tk, instead of doing this down here, we're no longer going to do anything with these root variables here. All I have to do is say app is equal to application. And then I can say app.mainLoop to run that main loop. Oops, and I almost made a mistake here. When we run this super.init, I don't know why I put that there at the top. This needs to be within our init function because we want this constructor initialized whenever we create our application, and all that's going to get done within there. So now I think this is much cleaner and easier to understand and a lot easier to maintain than what we saw before. So if I go ahead and run this, then we can see that we're still just getting our blank application for now. Now, one more thing about organization. This is more of a personal preference than anything, but when I'm looking at code like this, it logically makes more sense to me when the code that's first being run is at the top of the script. So for example, when we run this script, the first thing that we're doing is creating this application and then running that main loop. But that's currently at the bottom of the script, and we can't put it above our class because we have to define our class before we use it. But there's a super easy workaround to this. All we have to do is create a function at the top of the script and add the code there. Now, this is typically called something like a main function, but you can call it whatever you want. So I'm going to go ahead and do that real quick and show you what I mean. So here at the top, I'm just going to create a new function called main, and then I'm going to put everything within here. So app.application, app.mainLoop, and then below here where we were running that code, I'm just going to run that main function. And that's just going to do the exact same thing that we saw before, but now we have the code that creates the application at the top of the script. And while we're doing this, we may as well follow some best practices here and add a conditional that you all may have seen before. It's just this if double underscore name is equal to, and then within quotes here, double underscore main. And if it meets that conditional, then I will run that main function. Basically, all this means is that we're not running this main method unless we're running this script directly and not via an import or something like that. It doesn't have anything to do with Tkinter. It's just a common practice that you'll see in Python from time to time. And I do have a separate video explaining this conditional, and I'll leave a link to that video in the description section below if that's something that you're curious about. Okay, so now that we've got this simple application created using a class, now let's take what we had before and add everything back in. And we can do this just by adding them to our application class. So I'm going to copy a lot of what we had before, but use our class instance instead. So let me grab a few things here. So first of all, I'm going to get rid of a couple of things that we no longer need. So where we were using, creating that instance we no longer need. So let me go ahead and grab this section here where we're setting up our root and configuring some of that stuff. So I will paste this in here, get that correct. So this is where we were configuring the columns and the rows. Instead of root here, this is just going to be self. And I believe that's all of the customization that we had with our root application. Now let's look at our frames. So remember, we were creating two frames here that were basically identical and were repeating code, which should be a hint that we could probably do this in a better way. If we look at what we're doing here, we're creating a frame and we're adding that to our root application. Sorry, this is a little dark because it's commented out. And this frame has an entry field that's added to the frame. It has a button. It has a text list. And also our add to list function is the handler for some of the events on those widgets. So if we think about this, our frame basically has variables and functions of its own, which is a good sign that it could be a candidate for a class itself, allowing us to add those as properties and methods of that class instead. So let's see what this looks like now. So I'm going to create a new class under our application class, and we'll just call this input form since that's basically what we're using those frames for. So underneath here, I'm going to create a new class and I'm going to call this input form. And instead of inheriting from TK here, instead I'm going to inherit from the themed Tkinter because, or the themed Tkinter frame, I mean, since that's what we were using for those frames. So I will inherit from a frame here. And now let's go ahead and create our init function. I'll just copy that and paste it here. Now remember, when we create a frame, it actually takes in an argument. It needs to know the parent container that this frame will be added to. So for the arguments that we're going to get in this initialization here, we can add the argument of parent. It needs to know that parent container. And that's going to need to be passed into that frame's constructor so that it knows to add our frame to this application. So just like we did before, where we ran the constructor of this TK instance here, we're instead going to run the constructor here of this super, which is going to be a frame. And the argument that it's going to take is it's going to take in this parent argument so that it knows to pass that in whenever it creates the frame. So just like that, we now have a class for an empty frame. So now let's add those properties and our method to this frame class to customize this a bit. So first, let's copy the widgets that we added to our first frame. So down here, let me go ahead and I'm going to go ahead and grab everything that we did to this frame after we created it, except for the grid layout there. I'll save that for later. So I'm going to grab where we configured the columns and rows all the way down here until we get to our second frame of creating this text list. So I'm going to cut all of that out and I'm going to put this here within our init function. Let me get the indentations and everything correctly and uncomment this. And now I need to make a few changes here. So you can see that it's given me some underlines for some warnings or some errors in this case. So I need to change frame to be self. So we have self.column configure, self.row configure. When we create entry, we need to pass in self, which is this frame, as that entry's parent container. We haven't added our add to list function yet, so I'm not going to worry about that. And lastly, let's go ahead and change that last frame there as the parent for this button and this list box. Now I want these to be available within this frame itself. So here at the beginning, I'm going to put self dot in front of all of these here. And let me save that. Now, just to clarify, the reason I added self here before all of these is because I want to have access to these variables within the entirety of our frame here. Oh, and you guys probably noticed this way earlier than I did, but this isn't even in my frame. I don't know what I'm doing here. Let me put this where it's supposed to be in the frame. Sorry about that. That would have been a big mistake. Okay, so again, to clarify, the reason I added self.entry and self.entry button and things like that is because if we hadn't done that and we had just put entry, then what that does is it just creates a local variable within our init function, and it wouldn't be accessible within other methods and things like that within our class. So we want this to be accessible, so it's self.entry instead of just entry there. Basically, anything that you want to be able to access outside of just your init function will need to be prefixed with that. Okay, so now let's add our add to list function to this frame class as well. Now, if this was a function that was acting on your entire application, then you could add it to that application class, but this functionality is specific to our frame, so we'll go ahead and add it there. So let me go ahead and uncomment this and cut it out there, and within our input form class here, I'll add this in, get that indentation correct. Now, since this is going to be a method of our class, it needs to take self as the first argument. And now, since this is a method, we're also going to need to say self.add to list whenever we are trying to call this. So anywhere that we're using add to list, I'm going to say self.add to list there so that it calls that method. Okay, so now within this function itself, now that we have this inside of a class, instead of using these widgets that used to be in the global namespace, we can instead simply reference these widgets from the instance of the class itself. So to do that, just like we saw before, I can put self.entry and self.textList and self.entry there. And that's going to reference that specific instance of this class and not just something on the global namespace. And just by doing that, that's actually what's going to solve our issue that we saw earlier. So now to create some frames using this class so that we can see that that issue was solved, we can simply do that within our application class. So I'm going to copy that code that we used to create those frames before and see how this is now different. So here, where we were creating these frames before, I'm just going to cut this out. And up here within our application class, let me go ahead and paste this in and make sure that's indented correctly there. Now here, instead of creating a themed Tkinter frame and passing root in as the parent, now within our application, all we're going to do is create this input form, which is also a frame. And now we just need to pass in self as our parent container because this application is self, so it's basically the same as passing in root there. And this grid layout is just going to remain the same. We're still just adding this to that first column, so that looks fine. Now if I wanted to add a second class here, then I could do that as well. And all I would need to do here is say, frame2 is equal to input form, frame2.grid, and we could put that in the second column there. So now everything that we had before where we were creating these frames, so we created our first frame and then we added in an entry, a button, the function, and the list box. And then we did that same thing for the second frame as well. And we had that entry for the second frame, entry or the button for the second frame, and so on. Now, all of that is contained within this input form class. So we don't need to do anything else other than create that input form class like we did here and initialize that. That's already going to contain all of those widgets and actions for that frame. So now, since these are their own instance, we're no longer going to have that problem where our event handlers were referencing the wrong widgets. Since each of these frames now references its own widgets using the self keyword, we're working with instance variables of those specific frames instead of relying on global variables. And this should basically give us what we were originally after in that first video. So I'm going to go ahead and delete any of the commented stuff that's left because we no longer need this repeated code that we were using before down here. And now this is much more contained and is much more functional as well. So now let me go ahead and run this and make sure that this works and that I didn't mistype anything here. So we can see that we have our two input forms here, and I'll just say this and hit enter, and that inner binding works. Our button works in this first frame. If I hit enter there, that works. If I use the button, then that works as well. So our first frame is working, our second frame is working, and it's both laid out here in our application, so that seems to be good. Okay, so that works, but I have a feeling that some of you are going to look at this with these classes here, and you're going to be thinking, okay, now that was a lot to do in order to get our simple application working. Is it really worth it? Couldn't we have just used one of those workarounds? And I get that. It seems like if you just want a super simple application, that classes might be overkill and you just want to keep everything in the global namespace. But remember, we were changing what we had already written in the last video. If we'd written this from scratch, it really wouldn't have taken that long to just do it this way from the beginning. But also, even with simple applications, there's almost always something that comes up that we're going to want to add later that we'd overlooked when actually planning even a simple application. So doing it this way from the beginning just makes it so much easier than doing it the way that we saw in the last video. So for example, let's say that we have our two frames, our two forms here, our two input forms. But when we were planning this application, we overlooked that we also wanted to have a way to clear those list boxes of everything that's been added. So the way that we did it before, we would need to add a new button widget to both of those first and second frames separately. We would have to make sure that the event handlers reference the correct list boxes for each one of those frames. And that leads us right back to the situation that we had before and just leaves a lot of room for mistakes. But the way that we've done this here, it just makes it super easy. So if I wanted to put a clear button here, all I would have to do is go down to our frame class, and let's just add this second button right underneath our add button. So I will copy that and I'll paste that here, and we'll just call this entry button 2. And also we want the text for this to be clear, so I'll say clear there. For the command, let's call this clear list, and that is a method that we'll write here in just a second. And we also want this to be in the third column, so column 2 there, and that looks good for adding another button. And since we now have 3 things in our first row for this text list, let's also column expand this to 3 instead of 2. And now all we have to do is create this clear list event handler here. So let me just copy this method declaration here, and I will call this clear list instead of add to list. And I don't have a keyboard binding on here, so I don't need to accept that event. And now all I'm going to do is delete everything in this text list here. So I can just say self.textlist.delete, and it's going to be very similar to what we did to our entry here after we add it to the list and we remove everything from that entry. We're also going to do this with the text list and just delete everything from the beginning, which is this 0, all the way to the end, which is this constant within the TK class. So all we did was change our input form here. We made no changes at all to our application class or anything like that. So now if I save this and run it, then we can see that both of these now have a clear button. So if I add things back in again, everything's still working. And if I hit clear, then it only clears that left frame. If I hit clear here, then it only clears that right list box. So now I can close that down. So it just makes it a lot easier whenever we are wanting to add something to our application to know exactly where to add it. So there I wanted to change something in the input form by adding a button. So I just went in and all I had to do was change that input form and change no more of the application. I didn't have to touch anything outside of these classes here. And now that we have everything written down here, let's actually walk through this code just really fast and just kind of take a look at how it kind of logically flows a little bit better now too. So when we first run these scripts, it's going to run this main function here. If we go up, we can see we're creating our application and running that main loop. So then we can just look here that we have our application. We can see that we're setting the title. Everything with our main application is here. So everything from our main window configurations to what's added to that main window. We can see that we're adding to input forms here, so we can go see what's in there. And we can see that this has its own customizations and buttons and event handlers and things like that as well. So I think the layout is just much better. Now, a little side note here. Let me, you can see that this has been underlined the whole time here. This is just a Pylint warning for our event handler, and that's because Pylint gives warnings when you have an unused argument. So we need to accept this event object that Tkinter is sending to this function, but we're not doing anything with it in this example. And if you declare a variable that's not being used, the common convention is to put an underscore in front of that variable. So instead, if I just called this underscore event instead, then that will likely get rid of that Pylint warning and let it know that we know that we're not using that argument and that it's by design. That's just a side note that Pylint warning was bugging me, but it doesn't actually have any effect on our application. Okay, so we're just about wrapped up with the video, but I did want to mention another positive to breaking up our code into classes like we did in this video. Now, this might not be something that we think about until the application grows in size, but once we have a lot of different frames or pages for our GUI application, then these classes allow us to easily break these into separate files. So for example, if our input form that we created here is something that we use in multiple windows, we could actually split that out into a utilities.py file or something like that. And then within our main application, we could just say from utilities import input form. And that would clean up a lot of our code in our main files if we used imports instead. And these classes allow us to do that easily. But with that said, I think that's going to do it for this video. Hopefully you feel like you got a good understanding of why you'd want to use classes when working with Tkinter and a lot of the benefits it provides. In the next video, we're going to be learning how to use variables and effectively link values to widgets, which is another very important aspect to these GUI applications. But if anyone has any questions about what we covered in this video, then feel free to ask in the comment section below, and I'll do my best to answer those. And if you enjoy these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up. Also, it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, you can contribute through Patreon or YouTube, and there are links to those pages in the description section below. Be sure to subscribe for future videos, and thank you all for watching.